Chapter 24, Restoring the Lipid-Controlled Body. Restoring the lipid-controlled body means restoring a body whose behavior is once again governed by stable membrane architecture rather than by chronic biochemical improvisation. That distinction matters because the body is never truly controlled by isolated molecules moving through empty space. It is controlled through surfaces. Receptors read through membranes. Mitochondria produce energy through membranes. Barriers maintain separation through membranes. Immune cells decide whether to recruit or clear through membranes. The nervous system preserves precision through membranes. When those surfaces are compositionally coherent, the body behaves as though it has command over its own thresholds, its own inflammatory timing, and its own transitions between stress and repair. When those surfaces are structurally degraded, oxidatively unstable, overloaded with initiation-heavy substrate, and poor in the later phase chemistry of completion, the body begins acting less like an organized system and more like a collection of tissues reacting to one another's unfinished emergencies. Restoring the lipid-controlled body is therefore not about adding one good fat to an otherwise unchanged physiology. It is about rebuilding the material architecture through which the body regains control over itself. The first principle of restoration is that the body must stop being built from chronic contradiction. It cannot remain overloaded with omega-6 dominant initiation substrate, repeatedly exposed to oxidized lipid damage, continually re-triggered through barrier leak and metabolic volatility, and then be expected to resolve cleanly simply because some omega-3 has been introduced. That is not restoration. That is biochemical conflict. The lipid-controlled body emerges when the membrane reservoir is no longer dominated by escalation chemistry, when EPA and DHA are meaningfully incorporated into phospholipids, when cholesterol and sphingolipid-supported order are preserved rather than pathologized in abstraction, when saturated and monounsaturated fats provide enough structural resilience that highly unsaturated lipids can be held and used without turning the membrane into a chemically fragile field, and when the system as a whole is no longer being asked to operate under continuous oxidative and inflammatory assault. Restoration begins when lipids stop fighting one another inside the same tissue and begin serving their proper roles in hierarchy. This means the project is architectural before it is symptomatic. The body must first regain stable membranes because stable membranes are what allow receptors to interpret accurately, what allow gradients to hold, what allow inflammatory activation to remain proportionate, and what allow later phase resolution substrate to exist as something more than theoretical chemistry. Once those membranes are rebuilt, the body gains a different future. Phospholipids no longer release only the language of escalation. COX and LOX pathways are no longer crowded only by initiation-heavy traffic. The nervous system is no longer trying to signal through chronically oxidized surfaces. Endothelial and epithelial barriers are no longer as easy to destabilize. Mitochondrial membranes are more capable of preserving the structural conditions for ADP generation. This is the real meaning of lipid control. The body is no longer improvising from damaged materials. It is acting from designed materials. The second principle of restoration is that inflammatory completion must be rebuilt as a normal expectation of physiology rather than as an exceptional event. In the unresolved body, inflammation becomes sticky. It starts quickly, lingers unnecessarily, leaves residue, lowers thresholds, and turns ordinary life into repeated partial emergencies. In the lipid-controlled body, inflammation regains sequence. It initiates when needed, amplifies when necessary, and then resolves because the body once again carries the substrate, the membrane environment, the enzymatic flexibility, the barrier integrity, the macrophage competence, and the mitochondrial reserve required to finish what it starts. This is one of the deepest signs of restoration. The person stops feeling hijacked by every perturbation. Stress still happens, but it does not become as adhesive. Recovery becomes more believable. Small triggers stop producing outsized aftermath. Pain becomes less sticky. Sleep becomes more restorative. Food becomes less inflammatory by consequence, not only by rule. Stability begins returning not because life became easier, but because the body became better at closing loops. The third principle is that the lipid-controlled body cannot be rebuilt through suppression alone. Suppression can reduce visible inflammatory output, but it does not automatically restore order. Order is restored when inflammatory debris is cleared, when oxidized membrane fragments stop accumulating, when apoptotic cells are removed before they become fresh inflammatory fuel, when barriers close, when vascular surfaces stop behaving as emergency corridors, and when neural tissue stops interpreting ordinary inputs through the chemistry of unresolved danger. That means restoration requires active resolution. EPA and DHA must not only enter membranes. They must become part of a tissue environment capable of generating E-series resolvins, D-series resolvins, protectins, and maresins strongly enough that the later phase becomes more than a weak afterthought. The body must once again believe, in biochemical terms, that events can end. Without that conviction built into its membranes and mediator systems, it will continue acting as though defense is the only trustworthy mode. The fourth principle is that restoration must include energy. A body cannot become lipid-controlled if it remains ADP poor at the level that matters. Mitochondria must be able to fund cleanup, membrane repair, barrier reconstruction, and ordinary function without remaining trapped in emergency expenditure. This is why repair often fails in chronically inflamed people even when they begin supplying better lipids. The new material arrives, but the system still lacks the energetic coherence to use it fully. Restoring the lipid-controlled body, therefore, means restoring both the substrate architecture of resolution and the energy architecture of resolution. The membranes storing the language of completion and the organelles funding the labor of completion must both be repaired. Otherwise, the body receives better instructions but remains too exhausted to obey them. Real control emerges when signal and fuel stop working against each other. The fifth principle is that restoration is tissue-wide, not local. The gut must stop feeding fresh provocation into circulation. The vascular system must stop carrying chronic inflammatory tone from barrier to barrier. Adipose tissue must stop behaving like unresolved immune burden. The liver must stop handling every nutrient load through inflammatory congestion. The nervous system must stop interpreting ordinary life as continued injury. These are not separate projects. They are all expressions of the same larger repair, rebuilding a body whose tissues once again trust their own boundaries, their own membranes, and their own ability to return to baseline after disturbance. The lipid-controlled body is therefore not simply a body with better blood omega-3 levels. It is a body whose tissues have regained enough structural coherence that they no longer spread unfinished danger signals to one another so easily. This chapter must also end where the whole book has been moving from the beginning, toward the idea that control in physiology is not primarily top-down. It is not imposed by will, nor by one hormone, nor by one nutrient, nor by one signaling pathway. Control is distributed through material structure. The body becomes governable again when the membranes governing sensation, immunity, energy, permeability, vascular behavior, and repair are rebuilt into forms that can support proper timing. That is why lipids have occupied the center of this entire book. The body is built from them, reads through them, stores inflammatory features inside them, and resolves through them. When they are arranged well, the organism becomes calmer, stronger, harder to trigger unnecessarily, and more capable of repairing without residue. When they are arranged badly, every system becomes noisier, more defensive, and less able to finish what it begins. Restoring the lipid-controlled body, then, is not a narrow nutritional intervention. It is the reconstruction of the body as a system that once again behaves according to design sequence rather than accumulated damage. It is the return of the membrane as a trustworthy surface. It is the return of omega-3 as real resolution substrate rather than decorative supplementation. It is the return of macrophages as competent finishers, of mitochondria as dependable funders of repair, of barriers as meaningful separators, of vascular tissue as quiet control surface, of the nervous system as a signaling environment no longer trapped in chronic alarm. Above all, it is the return of the body's ability to end things properly. That is what control really means. Not the prevention of all disturbance, but the restoration of a biological architecture in which disturbance no longer has to become identity. Rebuilding membrane composition. Rebuilding membrane composition means rebuilding the physical surface from which the body interprets, reacts, protects, and recovers. That has to be stated with full weight because membrane change is not a cosmetic nutritional adjustment. It is a change in the material basis of physiology. A membrane is where receptors sit, where gradients are held, where phospholipids later pull inflammatory substrate, where mitochondria organize energy production, where barriers decide what stays in and what stays out, and where the body stores part of its future signaling language. If that surface has been built for years under omega-6 dominance, oxidative instability, poor omega-3 incorporation, repeated inflammatory remodeling, and weak structural lipid support, then the body does not just become deficient in one nutrient. It becomes physically biased toward lower thresholds, stronger initiation, and weaker completion. Rebuilding membrane composition, therefore, is the process of changing what kinds of futures the tissue is structurally prepared to generate. The first part of that rebuilding is displacement. EPA and DHA do not float above membranes as abstract benefits. They have to replace part of what is already there. If phospholipid pools are crowded by omega-6 derived substrate, especially in tissues repeatedly shaped by modern processed fat exposure, then the body is storing too much of the chemistry of initiation and too little of the chemistry of completion. Rebuilding means changing the stored reservoir. That requires repeated delivery of intact omega-3 in amounts sufficient to matter, enough time for phospholipid turnover, and enough reduction in competing omega-6 pressure that the new fatty acids can gain real structural ground rather than remaining token additions inside the same old architecture. The membrane has to begin carrying different material before it can produce different behavior. But rebuilding is not simply about increasing unsaturation. A membrane rebuilt intelligently is not one flooded with highly fragile polyunsaturated structure in a chemically hostile environment. Is one rebuilt into balanced competence. EPA and DHA have to be there because they provide substrate for resolvins, protectins, and maresins and change membrane signaling properties in ways that matter deeply for resolution. But they need to be held inside a broader architecture that includes enough saturated and monounsaturated structural support, enough cholesterol-mediated organization, and enough sphingolipid order that the membrane can remain coherent under stress instead of turning into a peroxidation-prone surface that carries good intentions and poor durability. Rebuilding membrane composition, therefore, means building a membrane that can both signal and survive. The oxidative environment determines whether this rebuilding holds. A person can increase omega-3 intake and still fail to rebuild useful membranes if the body remains under high oxidative stress, poor sleep, repeated glycemic volatility, ongoing endotoxin exposure, barrier leak, and chronic inflammatory burden. In that case, the new membrane material is being laid into a hostile construction zone. Highly unsaturated fatty acids may be damaged before they can become durable structural reserve. The tissue then appears resistant to change, but the deeper truth is that the new composition is not being preserved. Real rebuilding requires enough reduction in oxidative burden that the membrane can keep what it is gaining. Otherwise, the body keeps trying to construct better surfaces while tearing them down at the same time. Rebuilding membrane composition also changes thresholds. This is one of the most important outcomes. A membrane enriched in more stable and more resolution-capable substrate begins reading the environment differently. Receptors sit in a different physical field. Microdomains behave differently. Ion channels and transporters operate through a less noisy surface. Phospholipids release a different substrate balance when activation occurs. That means the body begins reacting differently not because a command was imposed from above, but because the surface through which it makes decisions has changed. Ordinary inputs stop crossing threshold so easily. Minor inflammatory triggers stop producing so much aftermath. Recovery after strain becomes less chemically expensive. The body becomes harder to push into escalation and better equipped to finish escalation when it does occur. That is what membrane rebuilding looks like when it becomes physiology instead of theory. The tissue-specific nature of this rebuilding matters as well. Neural tissue, vascular tissue, barrier tissue, immune cells, and mitochondria are not all remodeling for the same reason. In the nervous system, rebuilding membrane composition means preserving DHA-rich structural precision and future neuroprotective mediator capacity. In the vasculature, it means reducing endothelial reactivity and restoring selective control over traffic and permeability. In barrier tissues, it means strengthening membranes and junctional behavior so outside signals stop crossing inward so easily. In immune cells, it means reducing initiation-heavy substrate dominance and increasing the capacity to transition into cleanup and closure. In mitochondria, it means restoring membranes capable of holding gradients and funding repair without so much oxidative spillover. The body is not rebuilding one membrane. is rebuilding an entire membrane-defined civilization. Seen clearly, rebuilding membrane composition is one of the deepest acts of restoration in the whole system. It changes what the body is made from, what it can store, what it can release, how it interprets signals, how it funds recovery, and whether inflammation is more likely to become a successful sequence or a chronic identity. This is why omega-3 matters, why omega-6 competition matters, why oxidative protection matters, and why structural lipid support matters. The body does not heal only by reducing what hurts it. It heals by rebuilding the surfaces through which it becomes itself again. Re-establishing resolution capacity. Re-establishing resolution capacity means restoring the body's ability to finish inflammation as a normal part of physiology rather than leaving every inflammatory event half-complete. That is the real goal. The body does not become healthy by never activating. It becomes healthy by activating proportionately, clearing efficiently, and returning to order without carrying forward a residue of danger that lowers thresholds for the next event. When resolution capacity is weak, the body can still inflame, sometimes very well, but it cannot stop inflaming convincingly. Debris remains. Membranes remain unstable. Barriers remain too open. Cytokine tone remains too high. Macrophages remain too burdened or too poorly directed. Mitochondria remain too strained to pay for repair. Re-establishing resolution capacity, therefore, is not one intervention. It is the rebuilding of the entire chain that turns force into closure. The first requirement is rebuilding the membrane reservoir. The body cannot produce strong late-phase mediator biology for membranes that remain poor in EPA and DHA and overloaded with omega-6, dominant initiation substrate. Resolution begins with what the tissue is made from. That means enough intact omega-3 has to be absorbed, incorporated into phospholipids, protected from oxidation, and retained long enough to become part of the releasable pool from which resolvins, protectins, and marazins can later be generated. But rebuilding the reservoir alone is not enough. The body must also reduce chronic omega-6 competition so that when phospholipids mobilize substrate during inflammatory activation, the tissue is no longer drawing almost entirely from escalation-heavy stores. Re-establishing resolution capacity, therefore, begins by changing what kind of inflammatory future the membrane is prepared to produce. The second requirement is reducing repeated re-triggering. A body cannot regain resolution while it is being pushed back into initiation every day. Gut barrier leak, endotoxin exposure, ultraprocessed food intake, glycemic volatility, poor sleep, chronic stress, toxic load, mechanical overuse, and unresolved inflammatory debris all keep the system from staying in a later phase long enough to complete it. This is one reason so many people appear resistant to otherwise rational interventions. The body is not failing to respond in the abstract. It is being interrupted before closure can take hold. Re-establishing resolution capacity means lowering the number of signals telling the tissue that emergency is still active, so that the stop signal has room to become more than a whisper. The third requirement is restoring macrophage finishing. The body does not resolve just because recruitment falls. It resolves because cleanup succeeds. Macrophages must be able to engulf apoptotic cells, clear oxidized membrane fragments, process tissue debris, and help shift the site from inflammatory activity into reconstruction. If that cleanup phase remains weak, then every inflammatory event leaves behind a residue that justifies the next one. Re-establishing resolution capacity, therefore, means making the tissue more cleanable. That includes lowering incoming inflammatory traffic, improving membrane stability so less damage accumulates, and improving the conditions in which macrophages can work energetically, structurally, and immunologically. The fourth requirement is energy availability. Resolution is labor. Efferocytosis costs ADP. Membrane repair costs ADP. Rebuilding barriers costs ADP. Returning mitochondria, endothelium, epithelium, and neural tissue to ordinary function costs ADP. If mitochondrial function remains poor, the body may continue starting inflammatory events it cannot afford to finish. That is one of the defining asymmetries of chronic disease. There is enough energy for defense and not enough organized energy for closure. Re-establishing resolution capacity, therefore, requires more than better lipids. It requires a body that can use energy for completion rather than spending nearly all of it on partial defense. The fifth requirement is lowering oxidative instability. EPA and DHA are essential to resolution, but they are also vulnerable. A body that remains highly oxidized will keep degrading the very substrate it needs for later phase mediator production. Membranes rich in highly unsaturated fats only improve physiology when those fats are protected well enough to remain intact and function as stored precursor rather than as fresh oxidative debris. Re-establishing resolution capacity therefore requires a less hostile chemical environment, one in which omega-3 can be preserved, not merely ingested. Seen clearly, re-establishing resolution capacity is the return of biological trust. The body stops assuming every perturbation will become permanent damage. It stops holding tissues in chronic partial defense. It stops treating ordinary life as a string of unfinished emergencies. Membranes become better reservoirs for closure. Macrophages become better finishers. Barriers become better separators. Mitochondria become better funders of repair. Thresholds rise. Recovery shortens. Inflammatory events stop, leaving so much residue behind. That is what restored resolution capacity really is. It is the body regaining the ability to end what it starts and return to itself without carrying every disturbance forward as identity. Predictable signaling. Predictable signaling is what the body regains when membrane composition, inflammatory timing, and resolution capacity are restored strongly enough that tissues stop interpreting the same input in wildly unstable ways. A healthy system is not one that never changes, is one that changes proportionately. The same meal, the same mechanical load, the same immune exposure, the same stressor, or the same night of sleep loss should not produce radically different physiological outcomes from one day to the next unless the underlying context has truly changed. When signaling becomes unpredictable, it usually means the body is no longer operating from stable architecture. Membranes have become too reactive, cytokine tone remains too elevated, barriers remain too open, substrate pools remain too biased toward initiation, and the nervous, vascular, immune, and metabolic systems are all reading the world through partially unresolved tissue. The result is not just inflammation, it is variability. The organism becomes harder to anticipate because it is no longer signaling from order. This is one of the deepest consequences of failed resolution. A tissue that never fully clears debris, never fully restores membrane integrity, and never fully exits emergency mode does not merely stay somewhat inflamed. It becomes inconsistent. Receptors behave in a noisier environment. Vascular surfaces become more conditionally reactive. Pain pathways amplify on some days far more than others. Appetite and satiety signals become less trustworthy. Stress responses become exaggerated or blunted in ways that no longer feel proportional to the trigger. The body stops producing clean outputs from ordinary inputs because too much inflammatory residue remains between the input and the response. Predictable signaling, then, is not just convenience. It is one of the clearest signs that the organism is once again being governed by coherent structure rather than by unfinished defense. Resolution restores predictability because it removes the biochemical and structural noise that distorts interpretation. When neutrophil-heavy recruitment actually ends, when macrophages clear efficiently, when membranes stop leaking distress chemistry, when omega-3 derived later phase signaling becomes strong enough to matter, and when barriers regain selective control, the same inputs stop producing so much random aftermath. The body becomes easier to read because it has become easier for itself to read. Signals begin traveling through cleaner surfaces, cleaner mediator environments, and cleaner thresholds. That is what predictable signaling really means. Not rigidity, but reliability. The system can still adapt, but its adaptations once again follow understandable rules instead of reflecting whatever unfinished inflammation happened to be carried forward from the last unresolved event. Long-term biological stability. Long-term biological stability is what emerges when the body no longer has to spend so much of its future defending against the unfinished remains of its past. That is the deepest pattern running underneath everything in this book. Stability is not produced by holding the body in a fixed state and is not produced by eliminating every stressor. It is produced by the ability to pass through stress, activation, injury, immune challenge, and metabolic fluctuation without allowing those events to permanently lower thresholds, distort membranes, destabilize barriers, overload cleanup systems, and bias the tissue toward repeated reinitiation. A stable organism is not one that never changes. It is one that returns. It returns from perturbation, from inflammatory activation, from oxidative challenge, from immune stress, from nutrient excess, from nutrient scarcity, from neural strain. It does not have to remain in the chemistry of the event after the useful phase of event has ended. This is why long-term stability is impossible without resolution. A body that still knows how to initiate but has lost the ability to complete will gradually become less stable no matter how normal it may appear in snapshots. Membranes accumulate damage. Oxidized fragments remain visible. Macrophages remain burdened. Vascular surfaces remain reactive. Barriers remain easier to breach. Mitochondria keep spending on defense. The nervous system keeps interpreting ordinary life through chronic partial alarm. Hormonal signals become harder to translate cleanly. The person may still function, but function begins requiring more compensation and less true resilience. Over time, that compensation is what people often mistake for aging, fragility, poor stress tolerance, or inexplicable chronic symptoms. In reality, much of it reflects the accumulation of incompletely finished biology. Long-term stability fails when too many loops stay open. A stable body, therefore, has to be built from membranes that can preserve order under load, from lipid pools that do not force every inflammatory event toward escalation, from omega-3, derived substrate sufficient to support later phase completion, from barriers that can reclose after they open, and from mitochondria capable of funding recovery once defense has done enough. This is not a narrow nutritional statement. It is a system statement. The body remains stable across years when its tissues do not keep carrying forward the residue of prior activation, as if that residue were a permanent feature of life. That means fewer low-threshold flares, less sticky pain, fewer exaggerated responses to ordinary inputs, better metabolic flexibility, more reliable vascular control, more coherent endocrine signaling, and a nervous system that does not stay overprotective after the need for protection has passed. These are not separate wins. They are what stability looks like when it becomes embodied. Long-term biological stability is therefore the cumulative outcome of successful completion. Every time the body finishes well, it protects the future from the present. Every time it fails to finish, it drags the present forward into the future as structural burden. That is why resolution belongs at the center of health rather than at the edge of inflammation. It is the mechanism by which the organism prevents normal life from becoming chronic damage. A body that resolves well does not merely feel better now. It stays more itself over time.